Welcome to Lunch with Tech Leaders, where we have engaging conversations about software development and cloud engineering with industry leaders and subject matter experts. These episodes are created by the Great Lakes Tech Leaders, an online community of technology practitioners. Please come join the conversation by visiting gltl.rbn.ai. Again, that's gltl.rbn.ai. Now strap in, because we're deploying to production in 3, 2, 1.
Hello, and welcome to the latest episode of Lunch with Tech Leaders. My name is Jason Brown, and I'm a Cloud Solutions Architect with Right Brain Networks, and I'm your host for today. Joining me is software and data consultant Tom Kowalski.
Howdy.
And we also have business technology consultant Joe Coleman.
How's it going, guys? Just a reminder, if any listeners have any questions at all during the discussion here, throw it right there in the chat, and I'll make sure to jump in, make sure it gets addressed, and we all dive in on it. So thank you so much, Jason.
Yeah, thank you, Joe. And also joining us today is our subject matter expert, Preston Frazier, Senior Software Engineer from the Interoperability Institute. Welcome back, Preston.
Yeah, nice to be back with you guys.
Awesome. All right. In this episode, we're going to discuss serverless data stores. So let's get started. So what are serverless data stores? Just a quick definition. A serverless data store is it's a type of cloud-based service that allows you to store and retrieve data without the need to manage server infrastructure or provision resources. So it abstracts away the complexity of managing servers, scaling, maintenance, and so on, so that engineers can just focus on application logic and data management.
I noticed you didn't throw in the has to scale to 0 as part of your serverless requirement. That is part of mine, even though, yes, it's kind of going away, especially with latest AWS releases.
No, I mean, you bring up a very valid point, which is, like the true definition of serverless is having the ability for it to scale down completely to 0. So actually, I'd like to if you could expand on that a little bit, Tom, like what kinds of things would you consider would be serverless versus things that would not be serverless?
Yeah. To me, the one of the greatest benefits of it is being able to have production-like copies, right? If we're talking about functions, compute, data, to have production-like copies for your integration environments, your testing environments, dev environments, and being able to scale down to 0 enables that. When you have to pay even for a little bit, right? Just that uptime of like a keeping it alive, or that little bit of provision concurrency, they'll sometimes call it. It adds up. It doesn't allow you to have a development environment for every single branch, every developer, every team that's exactly production like. And I feel if you have that scale to 0, like a Dynamo, I'm sure we'll dive into some of these a little more, but like a Dynamo goes right to 0 if you're doing the that type of concurrency, the on-demand provisioning. You can have that. You can have exactly production-like copies in all of your environments. So that's what it means to me. I gotta throw that out there whenever we talk serverless. That scale to 0 is a big factor.
Right. Yeah. And I know in some of our previous conversations, we talked a little bit about Aurora and Aurora serverless. And I think that you had mentioned that like previously when Aurora first dropped, that it did have the capability to scale to 0, but sort of the V2 Aurora serverless, they took that away. Is that correct?
Yeah, they make you have at least like a 0.5 compute units as the lowest it'll scale down to for the version 2. So it's kind of a bummer, right? They kind of stopped development on the V1, and even though there's also features that are on the V1 that aren't in V2 yet. So, but yeah. It does not scale to 0, the V2. So.
Right. Yeah, I will say it is worth mentioning that you do get quite a lot of similar advantages from using the Aurora serverless V2, but there's still some things that it is lacking, to your point. But But yeah, I wanted to Preston to pick your brain a little bit about that. Speaking of the advantages, like what would you consider the key advantages of using serverless data stores like DynamoDB in AWS or Google Cloud Firestore, like over traditional database solutions?
I think it's like one of we just talked about, that cost factor. You really can control that based on what your usage is. That's a critical part of serverless. Getting started up, the overhead of, using the database. I mean, we know with cloud platforms that the services are managed. So even if you're not using a serverless data store like, traditional RDS, RDS is still a managed service. So it's still easy to get set up and get going. It's just that's not serverless. So I think it really comes down to that cost point. Using as much as you need when you need it on demand. That's where it is.
Right. Yeah. Yeah. And I sort of like to compare on the database side, I like to compare that to the compute side, where like with those RDS instances that you can configure similar to EC2 instances on the compute side. But with RDS, I mean, you'd still need to configure things like how much CPU and memory you're going to need for your instances, what the scaling looks like if it's in a cluster, backup and maintenance tasks, configuring like scheduled backups and things. So yeah, there's definitely a difference there in terms of the amount of management that is required. So, but yeah. So let's see. Tom, I was curious. Do you know of any like real world examples of like certain organizations that are leveraging serverless data stores for that cost effectiveness and scalability?
Yeah, I've done it in a few of the projects organizations that I've worked for. It's usually newer applications that can handle that. But yeah, pretty much anything new that I've built or a team that I've built, we've leveraged a serverless data store. I haven't ran into a situation where we couldn't.
Yeah, it's just that easy to get up and get started. Yeah, one thing too I'd like to also bring up is that we've been sort of comparing. We mentioned a few services already, like DynamoDB, and the there's a tendency for these cloud services that provide serverless data stores to be NoSQL. It's like a common theme throughout a lot of these cloud platforms. So I kind of like to dive in a little bit more into the NoSQL side of the conversation. Um, so Preston, like, how does the flexibility of schema-less data modeling in serverless data stores benefit engineers? Like, what are some of the advantage of that? Like doing a schema with data modeling without a schema.
Yeah, sure. I mean, I think, back to a previous question about an advantage. We talked about, startup time on developing. So I think, being able to prototype really quickly is, you know, a NoSQL database really lets you, prototype is how you want very quickly. You can transition. Not to say you can't drop and add columns in a relational database really fast in a other environment as well. But I think you really get options to prototype well. Obviously, as you move to production, it's easy on the fly too to change, the schema. I'm not saying you shouldn't have a good data model, because I've seen situations where having a schemaless data store, you get all different types of attributes in there as engineers add new features, and they're not still, staying true to a specific data model. Having a data model is still important to, know what the schema should be. But it certainly gives you that flexibility to add things. And and also, like I said, getting started, it's easy. I think, starting out with something like Dynamo NoSQL is a great start. But I've also had experiences and projects that I've built where eventually you move away from Dynamo because of a few reasons. Maybe we'll talk about that later. But it's a great place to start with in terms of just getting up to speed.
Yeah, and it's
Yeah,
it's kind of the opposite if you think about it. Everyone thinks like the flexibility, of NoSQL, but especially in the case of Dynamo, you really have to think about your read patterns and usage kind of up front and how that may evolve over time. Whereas you do have that flexibility in a relational database because you can just do joins anytime you want. But
Yeah,
with Dynamo, it really makes you you kind of have to think about those access patterns. Yeah.
exactly. You can you can index a relational database any way you want with a NoSQL database like Dynamo. You can do secondary indexes, but you really have to choose, like you said, what your read patterns are, because it's probably not as flexible in terms of querying data in every way you want. Um, it's more, I would say, more powerful, and you have a specific read pattern, like you said. You want to pull specific data in a specific way. And so once your use case changes, let's say you get another request from the business where, oh, I want to query data this way from your data store. Well, then you might get in a position where either you have to add a new index, or maybe you need to set up a different data model. So, agreed. I would say it's not as flexible as a relational database in that sense.
right. Absolutely. Yeah. Another thing that I wanted to touch on as well is I think you had brought up, as the nature of the application that uses the database changes and the data model changes, like how that propagates, and how that manifests in production. I can tell you guys, like, some of the most complicated aspects of some of the projects that I've worked on in the past are, how do we handle changes to the data model? How do we handle changes to the schema for like a relational database? There are some tools that help with that, and you can integrate that as part of like any CI/CD solution that you have when upgrading new versions. But there is a definite process that has to happen to handle changes to your data model for something that's already running in production. So one of the things I like about like Dynamo, for example, for the serverless data stores, is that the process by which you can do that is a lot easier, but there still needs to be a process, like what you guys are saying. So yeah, definitely in agreement there. So Tom, like what would you consider to be really good use cases where you'd want to use serverless data stores versus something like a more traditional relational database?
Uh, it comes down, I feel, also to the team and how comfortable they are, right? You can, there's little trade-offs here and there, but it really comes down to how comfortable the team is, right? If they are good with NoSQL and Dynamo, you can. It's pretty much limitless what you can do. There's going to be gotchas on some edge cases. So yeah, I really feel like it's not so much the application. It's more the team that's going to be working on it. I feel like plays a lot bigger factor into it. That's my experience.
Interesting. Do you have any thoughts on that as well, Preston?
Yeah, I think Dynamo is going to work for you. Probably in the beginning. I think maybe once your workflow matures, you might decide maybe Dynamo's not what you want. Maybe you will need another data store. But I think, in terms of getting off the ground, the cost factor for developing, it's a great place to start.
So what are some of the things that you think might change? Because I feel like
Yeah,
yeah,
I'd really like to talk about that.
dive into
You
it.
know, uh, one of the use cases we do at my company is we process a lot of messages. We route healthcare messages around, and we've used Dynamo for several different scenarios, and we've really ran into some performance issues with the amount of requests that we can send to Dynamo at one time. Even though it's a serverless database where it will scale up to meet your requests, it may not scale fast enough in terms of the number of requests you have. We've really identified that the way Dynamo scales is it expects a steady increase in your workload, whereas spiky workloads are not as well supported by that kind of system. And now there is potential where you can provision concurrency for the databases, but then you're starting to, I guess, lose the spirit of the serverless nature of Dynamo when you're provisioning this kind of concurrency already, where you're paying for potentially this amount of performance running and not using it. So we've ran into scaling events where we've had a large spike in data, and Dynamo just rejects those requests. So we decided that kind of workflow is not. Go ahead.
So is it on like a specific partition? I don't know, like dive into it and try to like solve this, but I am intrigued by it, right? I have seen it where, yeah, if it's like a hotspot, like a certain partition, right, like that won't scale fast enough. But if the workload is distributed, across, the keys are good and you don't have those hotspots, it's not as big of an issue. Yeah.
Yeah, I mean, this is a scaling issue on like putting records in the database. So it couldn't handle the influx of data, not necessarily reading that. So we decided to move off of that to a actually different service AWS supports called Elasticache. We decided to go to Redis actually for the use case we were working on, which is an in-memory database, and Elasticache allows the memory to scale pretty much on the fly, which is nice. So in terms of like high throughput, we ran into a little bit of issues with Dynamo there.
Right. Were you using Dynamo for some other use cases?
We do, and Dynamo works great for a lot of other use cases. We use it to store configurations for applications, data where you're infrequently looking it up. We store a lot of configurations where we can cache those configurations in our applications for a few minutes, so to cut down on requests. Since it's NoSQL, it's easy to query on partition keys and pull back specific data that you already know what to look for. Dynamo starts getting more and more, I would say, expensive, not necessarily in the cost, but in the performance when you have to do large scans on the entire data set. Use cases where you have to do that, or you need to think about it, but that's something you probably want to try to avoid if you can, scanning the entire database, because that is a slow process to do that if you have a lot of records.
Yeah, it should really only be like batch, or if you're doing like modifications to something, or like a analytical thing where you're moving it to somewhere else. But yeah, try to avoid the scan if it's like production customer facing, for sure.
Mm-hmm.
Right. Yeah. Actually, you just touched on something, Tom, that I really like about using Dynamo too, is that it's really easy to store like raw data. If you're part of if you have a process that needs to have some kind of ETL or data transformation, I mean, you can store that data directly in Dynamo without having to worry about the denormalization or the normalization or anything like that beforehand, right? So like you can just store it in Dynamo and then have that potentially trigger some kind of an ETL process that can pick it up and store it and change it, transform it to whatever form it needs to be for downstream processes, which is really nice. But anyway, sorry, go ahead.
I was just gonna, add on just another one of the kind of tricks, but this is kind of just with experience over using Dynamo over time. It's important to remember that the way it works is it will read a certain amount of data and then return it. So I think it's maybe 1 MB of data maximum that it'll return at a time. So it's important when using this data store that if you are doing like you're pulling back a large number of records, or your data store is very big, you might need to continue to iterate for a long time before you find all your records. I guess maybe to rephrase that is, even if you're scanning an index or querying an index in this database, you might need to continue to iterate. They give you a token back for the next page of results, so to say. And that's just one of the extra things you need to do. You can't just run the query once. You might need to run it multiple times to continue processing through the entire data set.
Right. Yeah. And I would consider that best practice. I mean, that's part of understanding your access patterns for your application and designing your table around that, building your indexes accordingly, making sure that you're, like you're saying, continuing to read, like with pagination, essentially. But yeah, what other best practices would you guys consider that, or would you recommend that people consider when using serverless data stores?
I think we touched on this earlier too. I think number of requests that you're making to the databases, for relational databases, connection pooling. In the serverless world, let's say you're using a container environment like Lambda, where maybe you're scaling up a bunch of containers, thousands, and those containers all have to connect to the database. You can easily run out of connections if your container amount exceeds the connection limit. And so there needs to be a design for how you're going to handle all those connections. Do you need to cache results from the databases and only connect to the databases so often? Do you need to set up some kind of connection pooling system? AWS offers something like I think it's connection proxy or something for RDS environments, and I think that works with Aurora too. To basically have a connection pooling service just for the databases. But number of requests that you're making to the databases, I think, is a huge consideration when you're working in a serverless environment.
Thinking about downstream, more with serverless compute, right? If it can scale almost, infinitely in quotes, you got to worry about downstream services. So it's always a gotcha sometimes that I've ran into.
Yeah. So like, yeah, and kind of going along those lines, like we've talked a little bit about it, some of the limitations. What are some of the other considerations that people should be watching out for, just to make sure that they start successfully, like to ensure their success when just jumping into Dynamo without having to go back and redo anything? Like, what would you guys consider some either other gotchas or considerations for somebody who wants to dive into serverless data stores and using them more frequently?
Yeah, with Dynamo, like we said, knowing those access patterns ahead of time and kind of walking through them and thinking about how things might change in the future. We're not over engineer, but you don't want to shoot yourself in the foot with your upfront data modeling. There's a great book. I think it's just like the DynamoDB book. I don't know exactly what it's called, but it's by Alex Debris. It's a great read if you're doing any type of work with Dynamo, especially and going over the different ways of doing the data modeling, especially around like single table design. So I'd recommend that for anybody getting started.
Great. Let's see. So we talked about a little bit in the beginning. We were comparing this to more traditional database service, sort of like RDS, for example. We talked a little bit about database maintenance and other similar features. For something like for serverless data stores, how important is it to have a solid backup and disaster recovery plan? Sort of, I guess we can start with Preston on that one.
I mean, imperative. For any production system, it's critical that you have a disaster recovery plan for when your database is when there's going to be an issue. And with Dynamo, it's a little bit handled for you. You can set up automated backups. I think it's there's a lot more you can do with the Aurora and RDS side to set up replication. I'm not sure if you can set up replication with Dynamo. I think you might be able to, but haven't done it before. But you certainly have to have those automated backups. You have to have, if you need replication, have that set up. And I think, we were talking about the advantages maybe of, quote, serverless data stores. One of the things Amazon likes to push on Aurora is overall, generally, they say it's a little bit better than RDS because of the faster recovery to fail over to a replica if there is an issue. So, I think they will say that Aurora's maybe a little bit better on performance if there's an issue that happens in your environment.
Yeah, that's exactly what I was going to say. That recovery time, the way that they do the database, the magic in the background, when you do like a point in time restore, things like that, it's actually connecting to data that they already have for you. So it's a lot faster. I don't know the metrics of it, but it's a lot faster than traditional data stores where you gotta fire it back up again, right? Go from an actual backup copy. Whereas, yeah, with AWS and some of their serverless data stores, it's really just spin up another endpoint that points to somewhere else on your data, like at certain time back. So makes it a lot faster.
Right. Yeah, that's one thing that I was hoping to address, because I wouldn't want somebody to fall into the trap of thinking like, oh, DynamoDB, it's multi-region, everything's, it's got, it's serverless. I don't have to worry about any of this stuff at all that I would have to normally worry about with the traditional relational database. But no, like it's something that you have to still take into consideration, or else, you could run into problems down the road. And it's nice to have, even just for peace of mind too, like to make sure that your data is backed up and recoverable in a reasonable time frame. So, but yeah, we're getting close to time. I just wanted to make sure we had a little bit of time to have, if either of you guys wanted to impart any closing thoughts, Preston, before we wrap up for today.
Closing thoughts would be, if it's, regardless if it's serverless or not, I think it's important when building an architecture to consider all your options, not just go with one of them because it's serverless or because it runs on RDS or a server. I think there are very important times to use one over the other, as we discussed before, what your design pattern is, what your architecture is. But if you yourself are starting out with development in a serverless environment, definitely give Dynamo a try, because it's the cost point right there is going to is be the best for you. Aurora is going to be a little bit more expensive to get started on, but in a production enterprise environment, there's benefits to using both of them, and it's important to be able to make the decision like we've talked about today.
Yeah, I would say, you want to leverage the highest abstraction that you can, right? That you're working on. So if there's a tool out there that does what, you know, you used to do, so you move to the cloud, so you don't have to manage the servers and things like that. So just going up that abstraction level as high as you can is better, right? And allowing your team to focus on providing value to your customers. So yeah, whether it's serverless or going down the line, if it doesn't meet your needs, just try to pick that abstraction layer, right? That takes away that undifferentiated heavy lifting that the AWS likes to say. So.
All right. Yeah, absolutely. So yeah, I guess with that, we could probably wrap up for today. I just wanted to take the opportunity to thank all of our listeners for tuning in to today's episode of Lunch with Tech Leaders. We hope that you found the conversation informative and valuable. And we'd love to have you join us again for the next episode, with our topic being building a strong SRE culture in an organization. As always, the episode will feature expert guests and interactive conversations, so be sure to tune in. Thanks, everybody, and we'll see you next time.
Thank you. Thank you.